Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to our comprehensive tutorial on Apache Airflow. In this video, we'll explore the fundamentals of Apache Airflow, a powerful platform for managing data pipelines and workflows. Originally developed by Airbnb, Airflow has become a cornerstone tool for data engineers worldwide. It's open source, allowing you to define, schedule, and monitor your workflows programmatically. So, why choose Apache Airflow over other workflow management tools? Well, Airflow uses directed acyclic graphs, DAGs, to represent workflows, making it easier than ever to visualize complex tasks and their dependencies. It also serves as a centralized platform that fosters collaboration among teams by providing a unified view of all processes. Additionally, Airflow supports dynamic scheduling, allowing tasks to be triggered based on specific conditions or events. Understanding the core components of Apache Airflow is essential. The scheduler is responsible for triggering tasks and ensuring they run on schedule. The Webserver offers a user-friendly interface to monitor workflows, review logs, and manage configurations. The Executor handles task execution, allowing tasks to be processed in parallel across multiple workers, enhancing performance. At the heart of Apache Airflow lies the concept of DAGs. A directed acyclic graph represents your workflow, where each node is a task and edges show how tasks depend on each other. This structure allows you to define complex workflows in an organized manner. Best of all, DAGs are created using Python scripts, making it easy to integrate with existing codebases. Apache Airflow comes packed with features that make it a versatile tool. The ability to integrate with external systems through plugins is one of its standout strengths. It also offers advanced scheduling options, allowing tasks to be retried on failure or scheduled at specific times. Additionally, Airflow provides robust logging and monitoring tools to keep track of your workflow's performance. To start using Apache Airflow, you'll need to install it. You can do this easily via pip, though some users prefer installing from source for customization. Before installation, ensure you have Python, PostgreSQL, and Redis installed as prerequisites. For newcomers, setting up Airflow locally is the best way to begin experimenting with workflows. Now that you've installed Airflow, it's time to create your first DAG. Start by creating a new Python script in the Airflow's DAGs directory. Use operators to define individual tasks and specify how they depend on each other. After writing your code, test the DAG locally using Airflow's CLI tools to ensure everything works as expected. In Airflow, operators are the building blocks of your DAGs. Each operator represents a specific task, such as running a bash command or querying an HTTP endpoint. Hooks come into play when you need to connect to external systems like databases or cloud services. If the existing operators don't meet your needs, you can always create custom ones to extend Airflow's capabilities. Airflow offers flexible ways to schedule your tasks. Cron expressions are a popular choice, allowing you to define schedules similar to Unix cron jobs. Additionally, triggers enable tasks to execute based on external events or conditions. With dynamic scheduling, your workflows can adapt and respond to changing data or system states. Once your workflows are up and running, you'll want to monitor their performance. Airflow's web UI offers a comprehensive view of all tasks, allowing you to track progress, review logs, and troubleshoot issues in real time. Logs are stored centrally and can be easily searched, making it simpler to diagnose problems. Furthermore, Airflow supports integration with external monitoring tools like Prometheus or Grafana for enhanced observability. As you become more comfortable with Airflow, you'll likely want to explore its advanced features. Plugins allow you to extend the platform's capabilities by adding custom operators, sensors, and other components. Airflow integrates seamlessly with popular systems like Kubernetes, Docker, and various cloud platforms, enabling scalable and robust workflows. The community has developed numerous plugins that can further enhance your experience. As you build more sophisticated workflows, it's important to avoid common pitfalls. Keep your DAGs simple and modular to maintain readability and scalability. Use retries judiciously to handle transient errors without overwhelming your system. Always implement robust error handling and comprehensive logging to facilitate troubleshooting. When your workflows grow in complexity, scaling becomes a consideration. Airflow supports horizontal scaling through the Celery Executor, which distributes tasks across multiple workers. For cloud-native environments, the Kubernetes Executor offers seamless scalability by provisioning workers as needed. To ensure optimal performance, fine-tune your database and worker configurations based on your workload. Apache Airflow is widely used in real-world applications. It excels at orchestrating data pipelines, automating ETL processes, and generating scheduled reports. By leveraging Airflow's flexibility and power, organizations can streamline their workflows, reduce manual intervention, and improve overall efficiency. In conclusion, Apache Airflow is an indispensable tool for managing complex workflows and data pipelines. Its flexibility, extensibility, and robust features make it a top choice for data engineers. We encourage you to continue your learning journey by exploring Airflow's plugins, integrations, and best practices. Engage with the vibrant community to stay updated on new developments and share your experiences. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.